Good morning, everyone, or good afternoon or good evening. Today's topic, or today's discussion, our topic will be on current and resistance. So, in this chapter, we will look into charges in motion. Okay, because during our discussion on the previous four chapters, it is actually focused on static to electrostatic. So that is the charges uh, that the charges that we are concerned with are actually considered as static para mas simplified siya now. This time, we will look into charges kung move na siya. So that's why we have current. Okay. So when these moving charges happen within a conductor, we now have an electric circuit. Okay. So basically, electric circuit depicts the overall energy as your uh, charged particle or electrons or holes positive travels or journeys around the electric circuit. Okay, so in an electric circuit, typically it contains circuit elements such as capacitor, the one that we discussed on the previous video, then resistors. Okay, so those are examples of electric circuit elements. So daghan pa yung mga circuit elements actually sa electric circuit. So we have load also. Okay, we have inductors. So as these charges travel in the circuit, there could be many energy transformations which takes place, such as energy being converted to sound or heat maybe and light in a light bulb. So examples sa energy conversion sa electric circuit, you have uh, your flashlight. So the moment you turn on your your flashlight, so the chemical energy stored in the battery is converted to electric energy, and then that electricity will drive the filament in your flashlight, the bulb in the flashlight to light up. So the electricity is converted to light energy. Okay. We also have sound. The moment you turn on your, let's say, the your MP3 player. So karaan na ka MP3 player. Your cell phone, maybe it contains uh, media players such as uh, maybe Spotify or YouTube Music. So the moment you turn or you hit play, so those electric energy is converted to sound. So daghang mga energy transformation nga nahitabo sa imong electric circuit. Okay. So circuits are indeed useful as they permit transport of energy without moving any parts except for the charged particles. Okay, and charged particles again ang nag-move. So we can find this electric circuit in all devices. As what I mentioned kanina, in mga mobile phones, in your TVs, computers, your radio, etc. And did you know also that that our body or your body is one big electrical circuit? Example. So our nervous system is one but specialized circuit which carries these important signals from one organ to another part of the body, and that those are carried in a form of electric signals or electricity, okay, pulses. And so studying the fundamentals and basics of properties of electric circuits will enable us to appreciate more and understand the working principle behind all of this wonderful stuff around us. So for this chapter, we will be learning about electric current and how does charges in the conductor move. And also we will be learning the meaning of resistivity and conductivity of materials. Okay, let's talk about electric current. So in the previous chapters, we consider electrostatic system, okay, where the electric field is zero everywhere within the conductor. Hence, no current. Okay, so walay motion. However, it doesn't mean that the charges, example electrons, are at rest since there is no current. So in a copper wire, wala pa say copper wire lang, wala pa nimo gibutang ang battery or gi-expose into electric field. Some of its electrons are free to move in all directions randomly. So those electrons are in the valence shell. So dili sila tightly bound sa atom. Okay? So they can freely move around, so randomly. So paspas ka na ilang motion around the order of 10 to the 6, so that's very fast. Okay. However, overall, there is no net motion of charges in a single direction. Okay, so hence no current. So it's like if you have this is cross section sa imuhang wire, so imuhang mga electrons ang move siya in random direction, right? But there is wala siya no net motion in this direction. Okay, in this direction. So randomly mag-move siya diha, but there is no net motion along in this direction. So hence no current. Okay, so no current. Now, when a constant electric field is applied, okay, so if na ako i-apply nga, okay, lahat na lang ang color. So if I put or I now expose this wire or this conductor with an electric field, this direction, okay, so if there is now a constant electric field applied to that conductor, so those charges, kani mga charges din will begin to move. Okay, will begin to move slowly in this direction. Okay, so in this case, na kay net motion in this direction, and so na kay current. Current exists. Okay, and these conductors or charges begin to move in this direction because it feels. Oh, okay. So if we want na ato ang motion is dira padulong sa right, so the electric field should be in this way. Okay, sorry about that. So this is the electric field direction, and we are talking about motion of electrons. So electrons will tend to move opposite to the direction of the electric field. So this is now the motion of the electric field, while this is the direction of the this is the direction of the electric field, while this is the motion of charges, electrons. So diha padulong electrons. Okay. So charges, electrons tend to move in a direction where it feels force from lower to higher potential. Okay. So this is at lower potential here, while this point is at a higher potential. Okay. So electron will tend to move from lower to higher potential. So diri siya padulong sa right. Okay, that will be opposite in direction. And this type of current is present in all parts of your electric circuit, in the capacitor, also in a resistor. Okay, resistor is a new added element to a circuit, and that energy can be transferred to a device in an electric circuit. Okay, the energy transfer mechanism is electrical transmission. Okay, so we'll touch that later. So for your electric current, so technically it is the rate of flow of charge through some region in space. And the SI unit of current is given by this, ampere. Okay? So ampere, that would be pila man ang charges nga ni flow per given amount of time, per second. So pila ka coulomb per second. And the symbol for electric current is given by I. Okay? So I na siya. So pictorially, the current can be viewed as shown in this figure. So to keep things simple, we assume that the charges are moving perpendicular to a surface of area A. Okay, so naa siya din surface area A. So the charges, in this case, it's positive, so it's moving in this direction. So that's perpendicular to the surface, and we can actually designate current as counting the number of amount of charges flowing in this area for a given amount of time. So the amount of charge that passes through area A in time delta t, small time. Then we can have the average current. Okay, that's what we call the average current. So if delta Q is the amount of charge that passes to the surface A in delta T, so we can have this. We can calculate the, as I've said, the average current. So thus, if a net charge, we also have net charge, this one dq. So this is what we call the instantaneous current. Similar din siya sa instantaneous velocity, instantaneous acceleration. When we say instantaneous, at that moment in time, you decide this is very, very small, dt. So, kaganina is ana man to, di ba? We have I equals delta Q over delta T. So, if we take the limit of this in such a way that T or delta T approaches zero, meaning at that moment in time, it instantaneously, unsa kay measurement sa current, pila ka ang charge na ni flow. Okay? So, from delta Q over delta T will be, it actually, ang label lang niya is we have dQ over dt. This is sa calculus naman. Okay? So, we have dQ over dt. That's the definition of current. So, in different materials, charges of the moving particles may be positive or negative. So in metals, it is the electrons, the negatively charged particles, are responsible for the motion or for the current. So in semiconductors also, we have germanium and silicon. So conduction is due to electrons and partly motion of holes or vacancies. Okay? So kanang holes na gimean the positively charged are just sites of missing electrons which acts like positive charges. So in electronic circuit calculations, people have made a consensus in the past that they will be using the conventional current. Okay? Conventional current. So mo nilang ginagamit, that is, the current flow is mainly due to the positive charges. Even though in cases we know that the actual current is due to electrons. Okay? So it is like the current is flowing from positive side of the terminal of the battery to the negative side of the terminal. Okay? Actually, it's a convention na siya. So we have, if you have your battery, this is positive, this is negative. So the actual current is the electrons ang nag-move, which is from negative to positive. But for consensus, ang ginagamit sa mga scientists and physicists and engineers, they use the conventional current, which is from positive to negative. Okay, dara ang motion sa current. In which ang motion sa current is due to the positive, okay, to the vacancies or the holes. So we can also talk about the current and the drift speed. So charged particles move through a cylindrical conductor. Let's say for this case, cylindrical siya. Then we have a cylindrical conductor with a cross-sectional area A. N is the number of mobile charge that which carries per unit. N is the number of mobile charge carriers per unit volume. So we can say that NA delta X is the total number of charge carriers in a segment. So we have your delta X, which is the small segment of length nga agian sa imong charged particles. That is also equivalent to this one, the velocity or the drift velocity times the amount of time nga travel siya from here to here. Okay, that's actually equal to this one, delta X. Okay. So if you have your N here, which is the number of mobile charge carriers per unit volume, and if you multiply it with this one, this is area times delta X. So this is area A times delta X. So that's actually volume. So we can actually get the total number of charge. So NA, okay, NA delta X. So this one is charge per volume, while this one is area times width, which is just volume. So cancel na siya. So we get actually the total number. This is the total number of charge of, or charge carriers in a segment. Okay. So as I've said kanina, when you have a conductor that is not yet exposed to an electric field, it has electrons, nasa yung mga free electrons or valence electrons that can freely move around the conductor at a very high speed. Okay, 10 to the 6 na siya iyang order of magnitude sa iyang speed, but there is no current, kay wala man siya drift velocity, okay, moving to the, let's say, to the right. So the moment you apply a potential difference, meaning mag-apply kag battery, okay, apply kag voltahe. So when you apply a potential difference across the conductor, an electric field is set up in the conductor which exists and an electric force on the electron. So let's say this is the direction of the electric field. So maka-feel lang yung mga electrons ng force, okay, move siya opposite to the direction of the electric field. So there is now what we call a drift velocity in this direction. Okay. So tara, drift velocity. So although hinay kay na siya, okay, but chain reaction man na siya. So in the entire, let's say if you have your conductor, so the drift velocity happens, it's almost instantaneously, okay? That's why if, so this is the drift velocity. Although hinay kay na siya, but connected man na siya, chain reaction. So the moment nga i-turn on mo ang let's say this is a circuit battery, let's say this is the electric field, and the ang motion is positive, so diri padulong. So the moment nga i-set up nimo ni siya electric field, instantaneously move na siya diri. So it's like automatic siya. So the moment nga i-turn on nimo ang switch sa light, so di na ka kailangan makulat og mga minutes para mo siga, right? So it happens instantaneously. So move siya. So that's how it works. Okay, so as I've said, the moment nga na kay potential difference na mo set up sa electric field, the motion of the electron is no longer random. Okay, na kay ginatawag na drift velocity. Okay, so as I've said kanina, this net drift speed is small. Okay, and the sharp changes in the direction are due to the collisions. So na mga collisions siya nga nahitabo, and that's why ang imong conductor is in the long run moinit siya because some of the energy is being transferred to the electrons katong pag turn on nimo sa potential difference, so the electric field. Okay, so this one we have the drift velocity. So what akong yung ganina, the electrons are already in the wire and they only respond to the electric field set up by the battery. So the battery does not supply the electrons. It only establishes the electric field, and once na electric field, maka-feel man ang electrons of force. Okay? So that's why na kay drift velocity na kay motion. So so in in effect na kay current. So this is a drift velocity sa for a 12 gauge copper wire carrying a current of 10 to 9 of 10 ampere. So this one's very small. Okay, so, or very slow na siya yung motion. So this is a typical order of magnitude for drift velocities. So another concept that we need to know is the current density. So current density is kanina na iyang unit. So that's current per unit of volume, per unit of area. Okay, so pila ang current niya per unit area. Okay. So a current density and an electric field are established in a conductor whenever a potential difference is maintained across the conductor. So for some materials, the current density is directly proportional to uh, directly proportional to the electric field. Okay? So and the constant of proportionality is what we call sigma. Okay, and that is called the conductivity of the conductor. Okay, conductivity property. So this relationship between electric field and current density was discovered actually by Ohm. So he's a German physicist, George Simon Ohm. Okay, so George. So he discovered this relationship between electric field and the current density. So if you turn on the electric field, kadako ang electric field, kadako po ng ihang current. Okay, and this phenomenon was sometimes referred to as Ohm's law. Okay, so Ohm's law states that for many materials, the ratio of the current density to the electric field is a constant. So sigma siya. So mathematically mo ni siya ang relationship niya. We have the current density, the conductivity, the sigma, so an E. So this is like a linear, right? Linear relationship. You increase the electric field, we increase po ang J with a factor of this one. So this sigma conductivity, and sigma is like the slope. Okay? So if mo siya i-plot, this is electric field and this is J, it's like a straight line. And the slope here is your sigma. Okay, ang slope niya, steepness. So materials that obey Ohm's law are said to be ohmic. Okay, ohmic. Because not all materials mo obey man og kuan, Ohm's law. So for materials, for simple case, materials nga mo obey og Ohm's law, then we call it ohmic. Okay. So for those materials nga dili mo obey, we call that non-ohmic. Okay, non-ohmic. So one thing to note, Ohm's law is not a fundamental law of nature. It is not a fundamental law of nature. Ohm's law is an empirical relationship valid only for certain materials. Okay? So true to selected materials lang siya. So dili sa tanan. So di siya fundamental kay kung fundamental pa na siya, it's true to all. So it's only an observed phenomena nga naka-observe ang relationship si Ohm between the current density and the electric field of certain materials lang. Okay? So this is George Simon Ohm, a German physicist, formulated the idea of resistance and discovered the proportionalities now known as the Ohm's law. Now we now look at one property of conductors, and that is resistance. So in a conductor, the voltage applied across the ends of the conductor is proportional to the current through the conductor. Tara, this one. Okay. And this constant of proportionality is called the resistance. Okay? So familiar na kita sa formula sa Ohm's law, di ba? Which is V equals IR or V equals RI. So you have your current and then you have your voltage. And the constant of proportionality is this R. Okay. So for a specific type of material na siya. So for example, you have ito yung naka-experiment naman before sa high school na namoy certain type of material o conducting material, and then you have your current and then voltage, tapos i-measure nimo ang different current response niya with different voltages nga input. So you will notice nga nani ang iyang graph. So because of this equation, because that is linear, okay, so it's a straight line, and the constant of proportionality or the slope for that line is R, okay, or the resistance of that specific material. So that's why we have this R equals delta V over I. And the standard unit or the SI unit of resistance is what we call the ohms. Okay. Or in symbol, we have omega. Okay. 1 omega is 1 volt per amp. Okay. So most electric circuits are Most electric circuits use circuit elements called resistors. Okay, and these resistors are able to control the current in the various parts of the circuit. So kailangan mo na siya kay for a particular device or equipment, kailangan man nimo i-manipulate kung pila dapat ang current nga pwede din hingad mga part and so on. For example, sa imong cellphone, different brightness, different colors corresponds to different voltage or current. Okay? So kailangan makontrol na siya, and resistors can do that. Makakontrol na siya kung pila dapat ang muagi nga current for that particular area. Okay? So standalone resistors are widely used, and resistors can be built into integrated circuit chips. So example kani siya. So values of resistors are normally indicated by color bands. So for example kani nga picture. So the colored bands on these resistors are orange, white, brown, and gold. So you have orange, white, brown, and gold. Nala siya gold dito kaya siya maklaro. Pareha na po na siya ana. Okay? So na siya meaning or code nga nung color siya because that corresponds to the value sa iyang resistance sa kanang particular nga resistor. So gi-code siya in color bands. So the first two bands give the first two digits in the resistance value. In this case, we have the orange and the white. So na siya value. Later on ako ipakita. And the third band represents the power of 10 kung multiplier siya. So let's say times 10 to the power of 2 ba, or times 10 to the power of 3 to the 4 and so on. And the last band, which is in this case gold, okay, na siya gold yan, di lang siya maklaro, is what we call the tolerance. Okay, ang yang plus and minus niya ba or error niya. Okay. So the complete list of color association of number and multiplier is given in this table. This one. So we have for black that corresponds to 0. So if you have your first two numbers, muna siya ang number na nag-represent sa kada color. Black 0, brown for 1, and so on. If sa third band, if you have this color, that represents this multiplier, ang yung value. Actually, the same na siya. Kung multiplier siya, instead na 0, it becomes 10 to the 0 or 1. Okay? This is 10 to the 0 or 1. Then if you have your brown, if it's a number, sa first two bands, okay, number, this is the first two bands. This is the third band. And then the last band. Okay. So for kung third band siya, so instead na 3, mo siya erase. Okay? The following numbers would be in this format, 10 to 10, 10 to the 1, 10 to the 2, and so on. And then for the tolerance, kanila na siya nga value, kanila siya nga color, the gold, silver, and colorless. That's why we are able to detect na ang first two bands are actually the orange and the white. So dili ka magbasa from the left. Okay, magsugod ka din because ang naa sa pinaka last is tulo naman ang option. It's either gold, silver, or colorless. So makaibaw ka nga mo na siya mo stand sa tolerance, which is the last band na siya. So example, you have this resistor, ang iyang band coloring niya kay have your red, blue, green, and silver. Okay. So say value ani nga resistance. So what is the value of resistance? Okay, for this resistor. So for red, stands for 2. If mapalit sa ato ang code, we have red is 2. Okay, this is 2. And then blue, first two bands correspond to number. Blue is 6. Okay, so we have 6. And then the third band is your multiplier. So nakay times 10 to the power of, multiplier man siya. So green stands for 10 to the 5. So this is 10 to the 5. And then your tolerance is plus and minus. So silver man na siya. So that's actually 10%. So that's 10% of yeah, we have 10%. So if you look at this point, so ang value sa resistor, if wala pa ang tolerance, we have this. So that is 26. So sumpay na siya. So 26 times 10 to the power of 5. Okay? Or that's 2.6 mega ohm. And then the tolerance is multiply lang nimo siya sa kaning 10 to the 5, which is 2.6 times 10 to the power of 5. Ihang tolerance. So that's 2.6 times 10 to the power of 5. Okay, so this is ohm. So that's how you read the typical resistors nga iyang code niya. Palit mo resistor, tanaw niyo ang resistor sa inyong uh, let's say na may broken nga device or equipment tapos sa sulod nakita niyo na resistor. So nana siya yung mga codes in bands, in colors na siya. Okay? Then another property of material is what we call resistivity. So resistivity is different from resistance because this is the equation for resistance. So resistance is dependent siya sa imong resistivity. Okay, this is resistivity. So it's like ang resistivity is a property of substance. Okay, and your resistance is property of an object. So it's like overall na siya. So ang resistance is depende siya sa imong resistivity, sa imong geometry, sa length, sa iyang area. While the resistivity mo siyang resistance, ang resistivity is it's like an innate property sa imong substance. Kung how well siya mo or how good or how bad siya mo resist sa imong current. And these are the typical values of resistivity for different materials. You have for silver, copper, and so on. If you notice, ang pinakagamay og resistivity diri is wait, lead maybe. Okay. Oh, it's not lead. Idako na siya. So, copper, right? So, gamay ang resistivity sa copper. Oh, mas gamay ang sa gold actually. Silver, I mean. So, kani siya mga material with low resistivity, that would mean effective siya or efficient siya mo kandak og electricity, right? Gamay man ang resistivity. That's why ang ginagamit sa mga wiring sa mga equipment sa imong sa tuang housing, electrical housing, copper gina siya, okay? Although mas maayo gid ang silver, but this is expensive. This is expensive. So if it happen nga silver ang ginagamit sa wiring sa inyong balay, so pagkaugmaan na wala may kuryente kay pangtangtang na inyong mga wire kay gididang na kay silver good, right? So copper is used because it's abundant and it's cheap. Okay? And dili po kay na nakalayo po ng difference, right, sa ihang resistivity. So that's it. Okay. So as discussed in the previous section of this chapter, let's take a look at these properties of a conductor. We have the current and resistance and how these two relate with each other as far as Ohm's law is concerned. So una kong na-mention kaganina, this is V equals IR. So if you plot the relationship between, kasi ang X nimo is the voltage. So usually mo man ni ato ang mo input, di ba? We have voltage. Mo increase nimo ang voltage or battery, unsay current reading. And then for that material makuha nimo ang ihang resistance or ang slope niya. This is in this case I equals V over R, okay? Or V equals IR. And sa kaninga let's say sa kaninga experiment o activity mo, this is 1 over R V. So this is your slope, right? So na ako is slope. So an ohmic device, this figure, has its characteristic of resistance being constant over a wide range of voltages, meaning the a 1 unit increase of voltage mo correspond sa 1 unit increase of current based on this on this slope. So linear siya. So 1-to-1 correspondence, increase ang voltage mo, increase mo ang current with the same amount. Okay? Increase nimo ang kaning amount, ang voltage mo, increase mo rin ang amount, the same amount, ang current. So that's why it's called ohmic. It's linear ang iyang relationship. So it's simple. And the slope is related to resistance. So on the other hand, we also have materials nga dili mo obey ani, dili siya straight ba. So materials nga dili straight. So dili straight, I mean dili straight ang iyang relationship, ang iyang graph when it comes to graphing its current and with respect to voltage. Okay, so it looks like this. So curve siya or bend. Okay, so non-ohmic materials in this figure are those resistance changes with voltage or current na dili siya linear ang iyang relationship. Okay, non-linear. So example of this type of material is a diode. Okay, example is a junction diode. Okay. Inani ang iyang behavior, and this is not V equals IR anymore. So di na siya inana. So it's like this is V exponent something. So exponential na ni siya nga behavior ba something like that. Okay. So we'll not discuss this anymore. So we'll not. So ang resistance po is mo affect po ang temperature. Right? So the greater the temperature, mo dako pa rin ang resistance because mo add man siya og kanang collision sa mga electrons nimo ba along the way. So ang path is mo-obstruct. So mo init ang material, mo saka po ang resistance. So dili siya efficient in conducting electricity. So a very good way nga makakandak well og electricity ang imong current is to lower the collisions, that is to lower the temperature. So ideally, once na ideally is very very low temperature is subject nimo ang wire og very very low temperature. It will only take one kick or one push lang sa mga electrons na then tangon na nimong battery, it will continue to flow forever na siya ang charge. Okay, wala may resistance, right? Ideally, kung wala resistance, magsige na ginag-flow. But because we cannot achieve that at absolute zero temperature, okay, ito ang wire. So that's why constantly sige tag provide og electric field sa imong current sa imong conducting wire. That's why na kay mga supplier og such. That's why na kay Beco and so on. So constantly sige na sila provide og voltage potential difference for your charge to flow. Okay. Then we also have semiconductor. A good maayo ang semiconductor is very important and applicable sa mga modern day devices. That's why natay cellphone, TVs, laptops, and so on because of these semiconductors and then transistors also. So example of a semiconductor application is this is I will discuss this later on kanang about magnetism, super magnet. Okay? So mo create na ni siya a very very strong magnetic field dinhi dapita if kani siya subjected siya at a very very low temperature. I think gibutangan ni siya og liquid nitrogen na very very low temperature na siya. So at a very low temperature, ang iyang magnitude sa magnetic field is would be 10 times greater than a normal electromagnet. So that's why it can literally lift. Okay? So na-apply po ni siya sa maglev train sa Japan. Maglev train. Maglev stands for magnetic levitation. So ang ilahang mga trains dito is powered by electromagnets, super magnets. Okay nga. Literally naglupad yun ang imong train, wala siya friction between the tires and the ground. Naglupad man siya. So the reason nga move na siya it's because strong kay ang magnetic field nga naa sa ground, okay? Na enough siya para mo levitate yun ang imong train. And then for this type of train nga nag-use siya og magnetic field, nag-levitate siya. So walay touching sa ground sa katong with respect sa ground and the tar. Less friction, so mas fast ni siya. Faster. Okay? Mao po na siya sa, I guess, yeah, sa bullet train sa Japan. You can search it up sa internet. Okay. That would be all for this discussion. And then if you have questions, feel free to comment lang on this video, or you can contact me, text me, or you already have my number, or you can message me sa Facebook sa tong group chat, or personally you can message me or email me. I will gladly reply. That's all, and thank you, and God bless. Stay safe.